Now let's look at example 15.3a. They're basically asking us to explain why the area under this curve from x coordinate 3 to 9 is within the range of 12 to 24 without integration. When you encounter this kind of questions, always note that the smaller range, so 12, is always the area of the triangle within the area of this curve, under this curve. And the larger area, 24, is the area of rectangle surrounding this curve. Now let's mark it out. The area of the triangle we're trying to find is this triangle. And the area of the rectangle we are finding is this rectangle. This is because we can see that the triangle that we marked out is within the area under the curve. So the area under the curve will always be more than the area of this triangle. However, the area under the curve is within the area of the entire rectangle. That's why the area of the rectangle is our upper boundary. So the area of the triangle will follow this as the base and this as the height. So the base is 9 minus 3, so 6 units. And the height is the y-coordinate of the upper point, so 4 units. That's why it's half times 6 times 4, giving you 12. And then the area of the rectangle is just 6 times 4. That's why you will end up with this range. Now moving on, example 15.3b. Given that this definite integral equals to 10, find the following. So for part 1, we can see that there are two different terms in this integral. So what comes to mind is that we should be splitting them up. So we can split them up firstly into 3gx plus 4dx. And then afterwards, we can take out the constant of 3 from our first one, and we'll see that we'll be left with this definite integral which has the value of 10 given in our question. Since this equals to 10, you know that the first term is just 3 times 10. And for the second term, we can just do our simple integration of 4, which will give us 4x. Then we'll sub in our upper bound minus subbing in our lower bound. That's how we get 4 times 5 minus 4 times 2, and our final answer of 42. Part 2, if you look at the bounds of the integral in part 2, you'll notice that it is flipped compared to the one given in the question. So if you recall, flipping the bounds means that you have to add a negative sign in front. That's why our answer is simply negative 10. Part 3, first thing we'll note is that we can split this definite integral up. Remember that the negative sign in front applies to both. Looking at the first two terms, you'll notice that we have the limits that we are focusing on from the question, so 2 and 5. However, there's a 4 as the upper bound on both sides. What we can do now is switch the bounds for the second term so that the 4 is the lower bound instead. To do so, once again, you have to add a negative sign in front. So this negative sign will simply turn into a positive because it's a double negative. And then for the last term, you can bring out the minus 2 since it's a constant. So it will be plus 2 outside of the integral, and x remaining inside. Afterwards, you'll notice that the upper bound is 4 and the lower bound is 4, which means that we can combine them into one integral with the upper bound being 5 and the lower bound being 2. So these are the type of properties that you have to look out for. If the upper bound of the first integral and the lower bound of the second integral is the same, you can combine them. If we plot it out from our graph, this is 2, 4, 5. The first integral is asking you to find this area, while the second integral is asking you to find this area. So adding them together will be the equivalent of finding your area from 2 to 5. So I can combine them with the upper bound being 5, lower bound being 2, gx dx. And of course you need to make sure that the term inside is the same term. And then plus your 2 or 5x dx. On the left, we can get the value from the question. So 10 plus, then we'll do our integration of x squared over 2, or square brackets, and the bounds on the outside. And then we'll sub in 4 squared over 2 minus 5 squared over 2 equals to 10 minus 9 equals to 1. That's how we get our final answer.